So what do you do when you got a part that's been bandsaw cut and you want to square up that piece of stock? Well, this is a pretty simple operation. You could do it in a manual mill, of course, if you had access to one, or you could do it in your CNC machine. Today I'm going to show you how to do this in a Haas mini mill with the older style controller. First thing I'm going to do is fixture the block in my vise with one of the bandsaw cut edges facing up, and, you know, as best as I can, approximately parallel with the axis of the machine. And then I'm going to use this face mill to remove some material off the top of this part now, so the face of the part, so that it becomes parallel with the axis of the machine's movement. I'm going to start the spindle, and so with this tool, I know I can spin up to 6,000 RPM. And so my tool is spinning at 6,000 RPM. Now I'm going to handle jog. I'm going to come down in Z. And I've picked the end of the part that I know is higher than the rest of them. It's got that little ski jump at the end there. I'm going to bring it down so that I just start to make it shift. So now we're making a chip on this part. I can change my direction of motion a little bit in the Y. Go to my X direction of motion. I can come across the top of the part simply by jogging with the handle jog. Now this isn't necessarily the fastest way to do this, but it is a method. You see we got a little high spot right there we touched.
At the end of the part, we come down a little bit in Z, reverse direction, and go back in the Y.
And you'll notice that I've got the tool not with the center of the tool driving down the part, but with the edge of the tool's contact driving down the part. And again, we took off a little bit of material. So we might as well come down another 20 thousandths, Z, tenth. So now I'm down 20 thousandths, go back to my X direction, and come across. And you'll notice when I start jogging, I move very slowly at the beginning just to make sure that that tool is moving in the direction I expect it to. I go back to Z, down another 20 thousandths, come back to my X direction, give it one or two clicks to make sure it's going the direction I want, and then feed across. And so now that surface is square, and it is parallel with the direction and motion of the machine. I'll go ahead and stop the spindle. So now that I've got the part out of the machine, I'm going to take these two edges, I'm going to put this in a vise, I'm going to hit those two edges with a file very quickly to deburr them, and then we're going to put this back in the vise with that side down on a set of parallels, so that now this edge is parallel with the motion of the machine. We're going to repeat that process, and we'll make this edge parallel with this edge. So that's seated on the vise. I'm going to tighten the vise jaws, and then I'm just going to repeat that process we did on the other side to now face off the top of this part to make it parallel. Again, it is possible to use the jog lock when you do this. I don't recommend it, but I have seen people drive that face mill straight into the tool probe and destroy the tool probe body itself. And you know, that's a $1,700 mistake that you probably don't want to make if you don't have to. So again, now we'll see that that side is completely faced off, and when we take it out of the machine, we'll be able to see that those two sides are now parallel with each other, and we'll be able to clamp on those two sides to hang the other two ends out of the vise, and we'll use a contouring or a side milling operation to make those two sides square. So now we've got two parallel sides that have been deburred with filing. And what we're going to do is we're now going to put the part in the vise in this orientation. We'll hang the end of it out of the vise a little bit like that, and we'll use, in this case I'm going to use a 1/2 inch 3-flute end mill that I had set up for another operation. We're going to use an end mill, and we're going to go along this edge of the part to make that now perpendicular to those two flat edges that we have. We're going to do this, open the vise up a little bit more. Wide enough so that that part fits in. I've selected some 1.25" parallels. I put those in, seated on the bed of the vise. And first I checked to make sure that there was no chips underneath those. I put my workpiece on the parallels. And again, I want to hang it out of the edge of the vise just a little bit. I'm going to push down firmly. We will start the spindle. And I'm going to again handle jog. And so with my face milling operation that we did to make the top or the two other edges parallel with each other, I didn't really care if we were climb milling or if we were conventional milling. But in this case, I actually really want to do climb milling on this end milling operation. And so we're only going to cut in one direction as we do this. You'll see how that works in just a second here. So the tool is spinning clockwise. And so that means what I want to do is I want to be feeding away from me right now towards the back of the machine when the tool is engaged with the material. And so I'm going to make sure I'm off the part. I'm going to come in Y to get to this end of the part. The bottom of the tool is just below the bottom of the workpiece. I'm going to come over in X very slowly until I just make a chip. Switch to the 1 pound per click increment here. And so we see that it's made a chip. I'll come back just a little bit to make sure I pass the end. I'm going to come in X. Come in 20 thousandths again, just like we did before. 1, 2 clicks. Go back to my Y direction. Which means if I press and hold the Y positive button, it'll feed away from me. And so if it's making contact all the way to the other end of the part, then we know that we've made this perpendicular. And so that end is done. And again, we're going to go back to the file, deburr this end of this part so that we could flip it around and hold it in the vise again.